What's machine learning? Machine learning, or ML, is a type of artificial intelligence that allows computers to learn from data without being explicitly programmed. Instead of following a set of instructions, machine learning algorithms are trained on data to identify patterns and make predictions. This process involves three key steps. First, training on data. Machine learning algorithms are given a large amount of data, like emails or pictures. This data is used as a reference for the algorithm to learn from. Second, identifying patterns. The algorithm analyzes the data to find patterns and relationships. For example, an email spam filter might look for patterns in spam emails to identify future spam messages. Third, making predictions. Once the algorithm has learned from the data, it can make predictions on new data. So the spam filter can now analyze new emails and decide if they are spam based on the patterns it learned. Machine learning is used in many different applications like spam filtering, facial recognition software, and product recommendations on shopping websites. Machine learning algorithms for geospatial data. Machine learning is a powerful tool for analyzing geospatial data, unlocking hidden patterns, and extracting valuable insights. Here are some common ML algorithms used in geospatial applications. First, support vector machines, SVMs. Imagine you have data points representing different land cover types, like forests, water, and urban areas. SVMs are adept at drawing a clear boundary between these classes in a high-dimensional space, allowing for accurate land cover classification from satellite images. Second, random forests. This algorithm works like having a whole forest of decision trees. Each tree makes a prediction based on a set of rules derived from the training data. The final prediction is based on the majority vote from all the trees. Random forests are great for tasks like land use classification and identifying areas prone to landslides. Third, convolutional neural networks, CNNs. These are particularly well suited for analyzing imagery data like satellite and aerial photographs. CNNs can automatically learn complex patterns from images, enabling applications like building detection, identifying changes in land cover over time, and even precision agriculture. Fourth, K-nearest neighbors, KNN. This is a simple yet effective technique for tasks like predicting real estate prices or optimal locations for new amenities. It works by finding the key nearest data points based on relevant features and using their associated values to make predictions for a new data point. Now let's talk about Scikit-learn, a powerful tool for implementing machine learning algorithms. Scikit-learn is a free and open source software library specifically designed for machine learning in Python. It's known for its ease to use, versatility, and extensive set of algorithms. Here's a breakdown of Scikit-learn's key features. First, user-friendly. Scikit-learn has a consistent API across different machine learning tasks, making it easy to learn and use even for beginners. Second, versatile toolbox. It offers a comprehensive collection of algorithms for various machine learning tasks, including classification, regression, clustering, dimensionality reduction. Third, model selection and evaluation. Tools to help you choose the best model for your problem and assess its performance. Fourth, robust foundations. Scikit-learn leverages powerful Python libraries like NumPy, SciPy, and Matplotlib for effective numerical computations and data visualization. Finally, open source community. Backed by a large and active community of developers and users, Scikit-learn benefits from continuous improvement and extensive documentation. In conclusion, by understanding and applying machine learning algorithms, especially through tools like Scikit-learn, you can unlock the full potential of geospatial data analysis.